Justin Kenny, and I'm the Green Infrastructure Coordinator for the Vermont Agency of Natural Resources. So I want to welcome you to today's webinar on Stormwater Master Planning. This is the fifth in a series of now 6 on this particular topic. And today we're going to be looking at a regional, multi-town approach to Stormwater Master Planning that has a particular focus on rural roads. Again, we're joined by Andres Chorizo of Watershed Consulting Associates, which is a Vermont-based firm specializing in stormwater management consulting services. We've been really lucky to have them providing the content for these webinars over the past couple months. And a couple quick notes before we get into the content. We are recording the webinar. I'm going to post a link to that in the next few days in our YouTube channel. Certainly send that out to anybody that's registered. All attendees are muted throughout the presentation. You have questions or comments, technical concerns, just type those out in the question pane. It should be on the right-hand side of your screen near the bottom, and I'll try to address those. Any questions really focused on the presentation we'll leave till the end, and then I'll ask those to Andres, and he'll respond after everything's through. Certificates, if you need certificates, I've been giving those out to folks, so just email me after the webinar, and I'll put your name on one and get you that as soon as I can. That's it for me. On to you, Andres.
Great. Thanks, everybody, for joining our last, my last webcast here. This happens to be probably the one I'm most interested in as well. I think it's probably most applicable for Vermont, so listen up on this one. Here we go. So we're going to talk about, this is template 3B, and this really is going to be the template that's focused on rural road erosion. People that should use this approach, this is really geared towards large rural areas where there's the extensive rural road network. If your focus area is in more urban zones, you should be looking at one of the other templates that we've already run through during one of the other webcasts. The funding available for this type of master planning template, first of all, the ecosystem restoration program funding is generally available for projects that follow all the steps of this template that we're going to discuss. It's an open question whether the Department of Housing and Community Development would fund these projects. It's more of a site-specific question. So that would be something that would have to be just on a case-by-case basis depending on the exact scope of the project, whether or not that would be fundable through their grant program. And these are generally fundable through the Better Back Roads program, which is really geared specifically towards rural road erosion. To start off, we're just going to get introduced to a case study up in Franklin County, Vermont on rural roads where there's been assessments that have already occurred. First, just to give a little bit of background on the context here in Vermont. Most towns in Vermont generally have very large rural areas with extensive road networks. And the urban cores are generally small, compact village centers where there's more of a cluster of impervious surfaces. But really, the rural road network is much larger in scale. And generally in these areas, road erosion is really the biggest stormwater management issue. In the state, the VTrans has over 11,000 miles of municipal roads, and over half of those are actually unpaved. So there's a huge network of unpaved roads in the state. And there's been quite a bit of research on the effects of unpaved roads and the erosion and sedimentation resulting from unpaved roads. And the recent research has shown that up to 30% of the phosphorus load to Lake Champlain is actually attributed to the unpaved road erosion. So it's a huge portion of the phosphorus load to Lake Champlain. and not just phosphorus. Road erosion contributes to just sedimentation of not only Lake Champlain, but also tributaries, upland tributaries, where sedimentation is a source of pollution and also leads to smothering of aquatic habitat. So sediment and erosion are major problems from road erosion, as are problems with infrastructure as well, just maintenance problems. We're going to go through some of that, but it's a very significant problem. And first, touching on the road maintenance issue, according to the Vermont Better Back Roads program, about 75% of unpaved roads need some kind of erosion control improvement. And for anybody that's gone out in the field, it becomes pretty clear right away after you start looking at a lot of back road areas. You don't really have to look far to find significant erosion, and it's not it's not always a problem of the town's not doing the maintenance. It's just the sheer scale of the network and the comparatively small amount of resources that are allocated to maintaining the road network. So we have to be really targeted in the approach, thinking about water quality impacts from back roads, really try to prioritize, what are the big problems that should be tackled first, and what are the erosion problems that maybe could wait because they're not really having as significant of an impact on water resources. Road erosion best management practices do save money, and they save money because, first of all, the town road guys don't need to keep coming back to the same problem and continually grading or continually trying to put a Band-Aid on an issue that keeps cropping up and kind of sapping the resources of the road crews, which in many cases are just 1 to 3 to 4 people covering a very large area. So the second, in times of extreme storm events, having properly maintained roads and proper erosion controls in place really does increase the resiliency of the road for extreme events, and would oftentimes reduce the impact, the severity of road erosion blowouts, due to an extreme storm. And I've seen this actually in a couple cases where there have been some really significant road damages due to an existing road erosion problem, which has basically just left that section of road very vulnerable. Large storm comes through, blows out the section of road, or basically moves sediment down slope, covers up a conveyance, and leads to a large blowout costing hundreds of thousands of dollars to fix. And then that same location, once repaired and repaired correctly, I've seen that same location survive even a more intense storm second time around with very minimal damage. So it really does work to kind of have a resilient road drainage network in the first place. So just to first discuss the general planning process with depending on what, we're going to go through a couple different examples of templates. This is really kind of the general planning step that one would take, I think, when embarking on assessing a rural area for back road erosion. And typically, the first step is to really, again, and this is really a common theme with all of these templates that we've been discussing through all these webinars, is what existing data is available to you. Really critical to, at the start of any master planning study, whether it be back road erosion, or even an urban assessment, you really just need to look at the context, where your site location is located, what watershed, what are the specific challenges of the watershed. Is that watershed impaired due to bacteria, due to sediment, due to temperature, due to stormwater flow in general? Is there any good data that's out there? Is any nonprofit group or USGS or research institution been monitoring water quality in the basin? Are there any basin plans that are already out there? There's several good ones out in many locations where there's already been some kind of a basin assessment with potentially already some projects that have been identified and ranked that could be really helpful and eliminate the need for you to do some initial legwork. Also, any stream geomorphic assessment data is often really critical, just to kind of key in on the areas of the stream which may be, say, specifically sensitive to increased stormwater flow, or it's, you know, any other areas where potentially there's high value water quality. You know, all these things could be gleaned by just doing a good, thorough existing conditions analysis. And a lot of times, it's a good way to start a project by pulling together all these resources and then basically summarizing them. It can be really helpful to whoever you're preparing this report for, as just a way to kind of collect and archive, inventory the existing work that's been done in the study area already. And then, you know, by that analysis, you could determine if there is a need for flow monitoring or a basin plan or something like a road erosion assessment. If one hasn't been done at all, you basically know that you're at square one with that assessment when you start. After that first initial step, you're really onto the new data creation phase, and I think that it's the most important step you could take, actually, is to meet with the local officials and meet with the public, because oftentimes in the smaller communities, the public and the local officials really do have a handle on the challenges in the town, and they've been dealing with these issues day in and day out. And oftentimes the really bad erosion problems have a history. You know, there's been attempts in the past to fix them. They've seen these sites performing or getting worse potentially, you know, after large storm events. So you can really learn a lot just by meeting first with the local officials, whether that be the road crew or the town manager, the public works director, and understand really what are the priority focus areas for the town. And after that step, it's time to head out in the field typically and really get to know the geography of the area that you're looking at, and view the projects and really calibrate yourself to the severity of the problems that you're going to be seeing. And I think that's really important, because oftentimes with the back road erosion assessments, when you first get on site and you go out and do your first field visits, you may be seeing some things that you may say, wow, you know, this is a really serious problem. And as you keep moving through the field and keep viewing more sites, my experience has been you've actually calibrate yourself, and oftentimes you realize that maybe those sites that you saw originally aren't really so bad, and they may be kind of a lower priority in the end because you start to see things that are, you know, even worse and even more of a severe problem. So you kind of get to calibrate yourself to the local condition. I think that's really important when we start talking about the scoring of these road erosion problem areas. We're going to be, you know, we want to look at ranking them because we want to be most targeted, most effective in our approach. And that calibration, I think, is critical in order to have an accurate priority list. And this problem area data sheet or something similar is an important piece of documenting the erosion problems that you find. This was taken, I believe, from the Fairfield project that was done. You know, this serves a number of purposes. Creating a form like this, you know, first it gives really good visual indicators of, so somebody that comes back to the site, which is often the case, which is most always the case if it is a real problem area that somebody wants to address. Somebody's going to have to come back and find this spot. It may not be the same season. There may be snow on the ground, or it's key definitely to have something on the aerial photo and have some good photographs and some good descriptors of the problem. And, you know, a form like this could be part of a final report that could be inventory, just to inventory that problem area. And oftentimes associated with the problem area data sheet would be a GPS point or a geodatabase, which is an excellent way to inventory all these problem sites is within a GIS geodatabase. And, you know, some of the criteria, the ranking criteria could be listed right on this problem sheet, you know, including some means of judging the severity of the problem, the likelihood of the occurrence of the problem, the feasibility of the solution, you know, whether it's something back of the envelope kind of solution, add a little stone, stabilize the head wall, the culvert, versus more of a comprehensive full engineering kind of study, which would really need to be done to really address what's going on, because a lot of times in some of the more severe problems you have issues of you know, really the whole road potentially maybe needing to be moved, or more of a systematic problem that involves, you know, many erosion sites kind of in a whole section of road, or a very large drainage area where you're dealing with a lot of water. After doing that, the priority site assessments, you know, that's really when you can calibrate and say, you know, what are the highest priority projects? And once that list is developed, you know, you want to gravitate really towards those high priority projects, and those are really the ones that are you want to be able to recommend for grant funding potentially to push those projects forward and get those fixed first. And so I'm going to go through a rural road specific process, which is going to kind of get into a little more detail on that general approach. And so we're just going to walk through that. And the first thing, just to go through using the existing resources, I had mentioned this, but you know, the two primary sources, the road crews are the really important resource. Again, you know, these are the people that are on the roads the most. Oftentimes, whenever I start any of these assessments, I usually do this initial meeting and sit down with a map and have these guys go through kind of all their focus areas, all the sites in town that they continually have to go back to. and are continually needing to address and kind of get a handle on what the nature of the problem is, how they're attempting to fix it, and oftentimes follow up that meeting with an actual drive around to actually look at the problem. And right off the bat, you can usually get a pretty long list of sites right off the bat by doing that work with the town road crews. The second source is this statewide GIS-based road erosion risk analysis data, and this is something that's in development. And I'm going to get into the details of that in a minute, but first, really, just to kind of highlight the fact that, working with the town road crews, it's very critically important, and it may not be a formal report. Oftentimes it's really just in, just the local knowledge of working, on the same road network for 20 years. And so, the challenge, I guess, is to extract that information. But, so it may not be in the format of a formal report, but, using that information will save you a lot of time, in the future by kind of steering you initially to where those problem areas are located. And so to get into detail a little bit on the second, the GIS-based road erosion risk analysis, the way that this is working is this is an effort that's been underway contracted out by the State Ecosystem Restoration Program. And this was the approach that's in development presently is based on a GIS model that was originally developed by the White River Partnership, University of Vermont, Friends of the Mad River, and the Central Vermont Regional Planning Commission as well. And the purpose of this really is to hone in on areas that should be focused on first, recognizing that the scope of the back roads is very large, and we can't just cover the entire road network all in one season, all at once, and we really need to have some way to, at the desktop, assessment level, after we've talked with our road crew guys, we kind of have their input in order to steer us, in what other areas do we want to cover. We want to do a desktop analysis. And so this is done using GIS, and the way it works is that the GIS analysis first would divide up Class 3 and Class 4 roads and driveways into 100-meter segments. And those 100-meter segments are evaluated for a number of different factors, which are listed here: the proximity to any water bodies, road slope is assessed for each 100-meter segment, the soil erodibility of that segment is analyzed, and other culvert assessment data is utilized within this assessment. Other culverts which have been flagged for being undersized have been integrated into the assessment, such that we're doing an analysis to figure out where all these risk factors overlap, and that's really what's shown on this map as the red areas, where the most of these risk factors are overlapping, meaning that those are, according to the GIS, the most susceptible areas to road erosion. And out of this analysis, we could basically develop an erosion risk ranking for the entire town network. And we could rank segments by high risk, moderate risk, or low risk, depending on how many factors are overlapping, and that's what's shown here. So this effort's been done. The first stage of this has been done, and I believe it is available on the Vermont DEC environmental interest locator. We're still kind of in the process now of I think fine-tuning this, and really we're going to be working on taking the next step to use this data to actually score the water quality projects in the field. And I'm going to get into a little detail on that next. And so the statewide road erosion inventory methodology, the GIS model that's been created will need systematic ground truthing. So once you actually develop this map, now it's time to deploy people to actually go out and look, and with a focus first on the areas in red where there are most susceptible to the road erosion. And so now the state is in the process of basically doing the second half, which is building on the methodology that's been developed for use in the Mad River Valley, that we first did our assessment for a number of years ago, and now also a bunch of work has been done in the Upper Winooski Watershed and also Lamoille using this scoring methodology, which I'm going to go through, which has worked well, but we're now taking this and refining it and making it available statewide and making a more streamlined, I guess, template which can be used to, when you're out in the field, score erosion areas by their risk to water quality impacts, and then develop a priority list of those projects, and then develop a capital budget, basically try to assess the cost of those projects, and then submit for grant funding. So just to go into the details of the methodology, the methodology that's been used up to date is really, when you go out to a site and when you locate an erosion problem, it's first on a data field sheet. Information is first collected on the erosion categories. So what kind of erosion is it that you're seeing? Is it a rill erosion? Is it incision? Is it a gully? Is it a slump? Or is it a scour? And I'm going to show some examples of that. Rilling being, small braided channels, something that may be graded out, from year to year. An in-ditch or in-stream scour is generally a more severe type of erosion, where just the velocity of the water is eating the side of the bank, undercutting the side of the bank or the bed surface. It's commonly found at a culvert outlet. A slump feature is when the weight of the road surface itself basically falls into the stream, and that can happen because of scouring down below. Basically weakens the bank, and then the bank slumps. So you can definitely have multiple types of erosion in kind of one area that you need to map. And then your incision or gully erosion is really where the erosion is actively down cutting in the road surface, or also oftentimes in the bottom of a ditch. You just see some active down cutting where there's active erosion going on. And defining the erosion category is important, because it just gives, again, a descriptor of, for the next person that might go out to the site, what are you seeing? What do you think is a problem? And where is it located? So it's just giving some reference to what this problem is. And where the erosion is located, for example, is it in the roadway? Is it in the shoulder? Is it in the ditch? Another physical descriptor. So these, your results can be interpreted by the next person that actually goes out and wants to view the site. The key indicators, though, for scoring the site for impacts to water quality are these that I'm going to go through now, and this is really this is how each road erosion site is ranked for impacts to water resources. The first parameter that we look at is volume, and it's the volume generated by the watershed that runs to and through the erosion area or point. Just to illustrate that, depending on where you are, if your erosion site is up kind of near the top of this hill, let's say for example, the drainage area for that erosion site is relatively small. You could probably see kind of the divide right at the top. It's a very small section of road which is actually flowing through the erosion area. If you're somewhere down in the middle of the catchment area, you're about halfway. You could see kind of maybe the dip in the road. If you look down, you could see kind of the crest up at the top. You're kind of about halfway down. You're in the medium area. If you're down near the stream, if the culverts are big, driveway culverts, cross culverts under the road are big, there's flowing water even when it's a dry period of time. The ditches are big, the rock is big in the ditch. Those are all pretty good indicators that you're somewhere down towards the bottom of the watershed where there's a significant amount of runoff generated during storms. And the reason that volume is so important is because the more volume, the more power, more energy that stormwater is going to have, and the more likely it is that a large amount of erosion could be moved to the stream from the erosion site. So we're more concerned with high volume sites than we are low volume sites. So this works into our scoring of overall impacts to water quality. Second factor that we look at is steepness. And when we look at the steepness, really what we're looking at here is the slope at and downstream of the erosion. So in this case, which is unlike the volume, from our erosion site, we're now looking downhill, and we're thinking about where does the water flow and the sediment from this erosion area go? What path does it take? And we're looking at that buffer from the erosion site to the nearest receiving water body, whether it be a stream or a wetland or a lake. So what's the slope of that? And obviously slopes vary all over the place. So we're making a generalized assessment of what is the average slope. If we take that slope overall, what's the dominant slope category here? Are we talking steep, greater than 15%, moderate, 5 to 15, or shallow? And the important piece here is that steep slopes, you're going to have much more likely that there'll be an opportunity for runoff and also sediment from the erosion site to continually travel overland versus on a shallow or moderate slope, having that runoff be trapped, just having the velocity slow, having that sediment settle out of the water and drop and be trapped within the vegetation before it actually reaches the stream. So again, we're trying to make a judgment on how much sediment, if at all, is reaching the stream from the erosion site. The next factor we're looking at is the opportunity for deposition. And so this is really looking at, again, this buffer area. And what we want to look at when we look at this buffer area are, if the opportunity would be scored low, within that buffer area you would generally have sheet flow over vegetated terrain. You would have channel turnouts possibly to vegetated terrain, meaning small ditch turnouts from the road that go out across the contour, basically spreading the water out, dispersing the sediment. You have visual keys where you can actually visually see sediment being trapped within the vegetation. Those are all examples of areas where you would have a low opportunity for deposition of the water body. A medium opportunity is really somewhere in between low and high. You're kind of seeing a little of both. You see areas where there's some defined breaks in slope. You're seeing deposition that's occurring before you get to the water body, but the water body is relatively close, and you're making a judgment that in large enough storms, there is likely a significant amount of that sediment reaching the water body. That would be a medium type site. Whereas a high site are really, and I think you know a high site when you see it after you do enough of these and you get calibrated. But the high site is really where pretty much every rainstorm there's a direct discharge, and you can see a visual indicator of sediment plume within the stream. Oftentimes you'll see just a delta of sediment kind of running out into the stream, or even for a good distance downstream. So those are really the sites that are the most damaging, and the sites that should be prioritized for water quality. Those are the ones that we want to get at first, because that's where sediment's getting into the stream, smothering the habitat, and also getting flushed downstream eventually to Lake Champlain. Also, we look at the ground cover to the water body, again looking at this buffer area and making an assessment of, do we have a really well-stabilized conduit there between the road erosion site and the stream, the water resource? Is it bare? Is it bare soil, which is very, will start eroding in itself. It's just not very well protected against any erosion. Or do we have a vegetated surface where there's opportunities for sediment to be trapped and dropped out of the water before it reaches the stream? So after we run through those priority scoring, each priority indicator is given a ranking, and the rankings are tabulated up in a spreadsheet, and the highest ranking sites are the ones where we have visual clues of direct discharge. We have high volumes of water running through the erosion site. Essentially the sites where there's a direct connection from the road erosion area to the stream. And that's really ultimately what we're trying to measure, is the connectivity between the erosion site and the stream. And the sites that have the most efficient connection are really the ones that that are going to rise to the top of the ranking. And so we're really working on that right now as far as streamlining that assessment, working on the methodology to actually inventory these sites. We're looking right now at developing potentially a simple paper version or an electronic application that could be used for people that have a smartphone, potentially GPS. We're looking at options that would kind of work for everybody, and this data would then eventually, once collected, would be joined to the risk analysis data, the original GIS data, using the unique identifiers. Basically, every one of those road segments that I showed you originally with that GIS analysis, the 100-meter road segments, has a unique identifier. And after going out and doing this inventory, the scoring would be linked back to that individual segment. So we would have a record of the fact that segment 001 was a very high priority site. And so that could be flagged for future grant funding implementation. So just to run through an example of one of these assessments that was just recently completed, the Lamoille County Road Erosion Assessment. The first step in this analysis was collecting the existing data. This is just an example map that was produced where you can see the priority ranking with the number of constraints. You've got the red areas being the most severe sites, basically by the desktop, where there's the risk factors were overlapping. And I didn't mention this, but what's happened also to date is not only just breaking up road segments and scoring segments of road, also scoring individual points. So you can see there's segments which are labeled by the line features being red, yellow, and green, but then also specific points where you have 5, 4, 3 constraints. And by doing that, it just gives you a little more flexibility to understand that, well, geez, this is a really high priority road segment, and that kind of has some importance to know that when you're planning your assessment, but also that, geez, this one point area has really got a cluster of these multiple indicators. So, geez, that must be that specific point on this road must be a place where we would want to go visit first. And so, with the Lamoille project, the GIS data was first used to do this assessment. The initial inventory of field, based on the field investigations, was completed. Spoke to the road foremans in each town and really got their information on existing sites, any new sites that they knew about that have just cropped up from a recent storm event, for example. And this analysis was done for the towns of Johnson, Belvedere, Eden, and Wolcott. And I believe, Wolcott, Cambridge, and Elmore were done last season. Waterville, Johnson, Belvedere, and Eden were done just this most recent season. The step two, the staff collected the field data for the selected erosion sites, and they were using a Trimble GPS unit with a data dictionary loaded into the GPS unit, which could basically have a template that they could do the scoring matrix efficiently using that template. And then ultimately the sites were scored and ranked, and the highest total scored sites were really the ones that were targeted for design and implementation. And that really leads to step three of these processes is, once you kind of have that list of priority projects, you typically want to take the top tier projects and push those forward to design. And what we've done in the past is for the top sites, generally the erosion categories that we're over time and time again we were seeing, they could really fall into just a number of categories which you would see repeated from town to town to town. And so really with these erosion sites, you could develop a set of typical details that could be applied for depending on what your erosion site looked like, where the erosion was located, the amount of volume flowing through the erosion site, the room that was available for a new ditch, the specific constraints on the site. So what we did was develop a series of typical details, A through, I believe it was K, and then referenced those typical details at each location. And with that information and with a volume calculation of the materials that would be needed to implement the fix at one of those sites, coupled with, the reference. This is just an example reference of one of the typical details here. With that information, you would have ready a grant application and then the guidance necessary for the town road crews to actually go out and fix a lot of these problems. And obviously not all these problems are simple, kind of more of a back-of-the-envelope type fix, which can be applied, which this type of approach is good for. Sometimes we would flag a full engineering site fix where the problem was just deemed to be too severe to basically try to apply typical detail. It would rather involve a more comprehensive investigation to really figure out the best solution. But really, probably 95% of the erosion sites that you encounter can really be fixed by standard practices that are familiar to a lot of the road crews. And oftentimes it's just a matter of guiding the road crews to the erosion sites that they need to be most concerned with for water quality, and then giving them the recommendation as far as what approach to take. What size stone, how much, an erosion blanket specification. So just providing a little bit more detail than they might have otherwise in terms of design, and also the specific location is really can do the trick. And that specific template, all these that we've discussed, is really applicable again towards the rural road areas. And for areas where there's the urban core, the village areas, you may need to use a different template. This template is not really applicable for the town centers. And throughout the webcast, we've introduced the other templates, and you may be looking at going to perhaps template 1, A, B, or C, which are really focused on the smaller watersheds with either the end of pipe or LID management, or possibly template 2A or B, which is more the site community scale, either an end of pipe or LID management, also with allowances for basically build out and master plan developments. So where you're analyzing future conditions as well as existing conditions. Or template 3A, which is the large watershed, or even regional approach for both end of pipe or LID management. And in all these areas, as I touched on in one of the previous webcasts, depending on the issues within your specific stream, you may also be subject to looking at the flow restoration planning, or MS4 requirements, which are in place in a lot of the larger urban areas where there's stormwater impaired streams, which are now being subject to flow restoration planning TMDL plans. And when we look at the state's master planning template and the model outline achievement, does this approach meet all those criteria? It does. It satisfies each one of these steps, which are outlined here: defining the problem, looking at the existing data, summarizing that data, inventorying that data, collecting new data, working the data into the program of the municipality, and then providing a good summary and recommendations for future work, and documenting inventorying all the problem areas, prioritizing the problems, and basically leaving off where somebody could pick up, the next field season and basically keep ticking off the high priority projects. And that is a summary of the template 3B.
Excellent. Thanks, Andres. So if folks have questions, send them along. We'll get those answered. Just want to note that we did add a sixth webinar, and I've emailed everybody the link to register for that. So anybody that registered for this set of webinars should have that. But that's going to take place on Tuesday, November 25th at 1 o'clock. So that's Thanksgiving week. That one's going to focus on the Crosby Brook Restoration Study. And that looked specifically at discharges along Route 5 and Interstate 91 in the vicinity of Crosby Brook down in Brattleboro, which is a 303D impaired waterway listed for sediment pollution and habitat alterations due to sedimentation, channelization, and buffer loss. So, we wanted to add that one. We've been talking about these templates, and that's a pretty nice case study of how the templates are being used on the ground. So I hope some of you will join us for that. And I don't see any questions coming through yet. I'll give it another second or two. There's one. Bob Hyams. So do you have any experience with A&R Atlas delineating a watershed function? Seems like that data would be of use. Have you used that before? I have, but
You have?
yeah.
Yes, I believe I have. I think that one of the challenges is that the data, if you're talking about in the context of these erosion assessments, say you wanted to determine when you look at the volume criteria, you want to determine, are you in a low, high, or medium volume area. You wanted to delineate your watershed. I think a lot of times you're limited by the data quality there. The data is not going to be good enough oftentimes to pick up on kind of the subtle things, all the cross culverts, all the ditch work. A lot of times you would have to actually, if you wanted to try to map out your watershed from your erosion site to see what the contributing drainage area is, oftentimes unless you have really good data, LiDAR data, 2-foot contour data, oftentimes it's best just to try to walk the area and map it with your GPS. I wouldn't tend to rely on the Atlas for that because I think that you just don't have enough data to really accurately delineate a small enough range.
Yeah, I would echo that. The data on there is pretty coarse. It's really just delineating a watershed based on topography. From my experience with that, it's good for getting a rough estimation of watershed size, but it is somewhat limiting. It's only able to delineate watersheds based on, I think, the streams layer.
Streams.
So if you click on another location in the landscape to delineate a watershed, it's going to randomly place that point that you've selected somewhere on the nearest stream. So it's not actually going to just delineate a watershed from a point on the landscape. It's actually going to delineate it from a waterway that's been defined in the Atlas. So in that respect, it is limited. But in terms of just getting a general idea of how big a watershed is, it's useful. Yep. Yep. And I don't see any other questions. Yes, you covered it all. That's great. Awesome. Well, so thanks everybody for participating. Thanks again, Andres, for this webinar and all the other ones. They've been really great. I think really informative. If folks have any follow-up questions or feedback, don't hesitate to contact me. Catherine did ask if we were able to share the LID alternatives assessment forms and the problem area data sheets. I linked the data sheets in the answer box, but I will send those out in an email, try to scrounge that together and get those out to folks. Then yeah, hopefully see you all for webinar number 6. So have a great day, everybody. Thanks a lot.